Hi everyone, let's solve this problem n queens. The n queens puzzle is the problem of placing n queens on a n cross n chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the n queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of n queens placement, where q and dot both indicate queen and the empty space respectively. So in this example n is 4, so we have a 4 cross 4 chessboard. In this case, the answer, if you see, every row has empty spaces. Let's say first is empty space, then queen, then both empty spaces. So this is how we are going to represent our every row, and one array in the result array would be a single solution where we can place queens without attacking the other queens. And we have two possible solutions for this. So now let's try to understand how we can solve this using backtracking. So first let's understand how a queen can move and what all directions it can take. So if the queen is here, it can move towards right, left, top, bottom, diagonally, on both the sides. So this is how a queen can move, right? So in that case, what will happen is one queen can be placed in a row, column. Let's consider diagonal 1 and diagonal 2, right? So we have to ensure that before, let's say for example, I place my queen here, I can place it in any position in the first row because we do not have any idea where other queens are. So let's say I place in any of the positions in the first row. Then if I have to place the second queen, I have to check if, let's say second queen I'm trying to place here, I should check if there is a other queen in the diagonal, top, right, left, bottom, and all of that. So if all of these conditions are matched, only then, like when I say all of these conditions are matched, diagonal 1, diagonal 2, if queen is not present in any of these row, column, diagonal 1, diagonal 2, only then we are going to place it in a particular cell, let's say R comma C. So that is how we are going to place the queen. So now it's very easy to know if so let me again. So it's very easy to know if the queen is placed in the row or not, because we can just, when we place the queen, we can just move to a next row. We don't really have to keep iterating over all the elements and then move to the second row, because we know that once we place a queen, we cannot place any other queen in the same row. So we just move forward. So we know the row position directly. And for the column, we also get to know the column position, right? Let's say this is the column, this is the row, 0, 1, 2, 3. It's easier to identify the column as well. But the trickiest part now is that we need to figure out what will happen in case of diagonals. So for that, let me draw a line. Let's call this as D1. And in D1, 0, 0, 1, 1, 2, 2, 3, 3. Let me take one more diagonal. So this is 1, 0, 2, 1 and 3, 2, right? Let me take a D2. There will be a different diagonal where we have this diagonals, right? Let me write the positioning of this elements. So it's 3, 0 and we have 2, 1 and we have 1, 2 and we have 0, 3, and the other one is 3, 1, 2, 2 and also 1, 3. So these are row comma column positions. If you observe a pattern in this, all the positions, its r minus c is constant, right? In this case, r plus c is constant for a particular row, for a particular diagonal, sorry. So 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, 0 plus 3 is also 3. And if we take the other diagonal, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4 again. Same applies to r comma c. So we can easily identify if the d1 has r minus c, that means we cannot place that queen in that particular diagonal, and in case of d2 it's r plus c. And for row it is pretty straightforward. For column, we will again maintain our column hash set. All of them will have a hash set where we will maintain if we can like r minus c, r plus c and a column. So based on that, if the value is already present, that means we cannot place in d1 or d2 or c1. Then that means that like any one of them, let's say if I cannot place in d1 or d2 or column, that means if I cannot place in one of them, that means I cannot place that particular queen at a point r comma c, right? R is row, c is column, and this is applicable to a particular board position. Let's say this can be r and c, right? I'm talking about that r comma c. Now let's try to code this up. I hope I hope the solution for checking the diagonals and the column is clear. I just want to clarify why we are not placing all the elements in every element in the row and checking, because once we place an element in the queen, we are sure that we will move to a next row. So immediately we move. Once we place the queen, we move to a different row. So we are not going to worry about the row placement here. And one more thing is that we don't have to place like brute force way, like check all the positions and stuff like that, because we can check that positions based on a d1, d2 and column hash sets. So now let's try to implement it. So first we will have column new set, let d1 new set, let d2 new set, and we have to create a board. Let board is equals to so this particular statement is nothing but creating a n cross n board with all dots in place. That is all it is doing. And then we have a result which is an array, and we are going to return the result. That is all we are going to do. Now we will call backtrack function, where we obviously have to send our board n result column d1 d2, right? All this data has to be available for the backtrack function. Now let's write the backtrack function with board n result column d1 d2. This call, let me make it as d1 set, because it might be confusing with respect to the column, right? So this is a set, this is a set, this is a set. we also have to pass the row. Row is nothing but initially we start with 0. Now let's try to write the backtracking code here. Let's say first let's write the base case. If my row is equals to n, that means I have reached the step where I found all the queens being positioned in the right places without colliding with each other. In that case, I have to push into my result. I have to push the board. So I also have to ensure that every row is a string, not an array. Currently we have a array, so I have to, this will be a row actually. So every row dot join of empty string. So it should be joining with empty string. And then once this is done, we will return from here. And then we will iterate over columns. How many columns will be there? Obviously there will be n columns, so I don't even have to calculate it. So it will be c less than n and c plus plus. In this case, now if at all I have my r comma c, right? If I have if my call set dot has column or d1 set dot has our d1 set is r minus c or d2 set dot has of r plus c, which we have already discussed. That means we cannot place that queen, so we will just continue to the next column. And now what we have to do is I have to insert call set dot add. I will insert the column d1 set dot add. I will add r minus c. d2 set dot add r plus c. Then I will change my board of r comma c to q because I am placing the queen. Then I will call the backtrack function with board. N will be remaining same, result will be same, call set will be same, d1 set also will be same, and d2 set as well. Now since I have already placed my queen as I discussed in the diagram as well, we will just move to the next row. How can I move to the next row? By just calling r plus 1, right? So after backtracking, I have to remove my column from call set. I just will copy all of the statements which I have done above and remove them. This is similar to the backtracking which we have seen in the subsets. And since I have inserted the queen, I should also remove it. If I have to remove it, I just have to make the cell with dot. I hope it should work now. We are passing board and result, call set 1, call set 2, and the current row we are passing it as 0. Let's try to run it up. Okay, this should be good. Cool, let's try to submit it. I hope the solution is clear. Now let's try to understand the time and space complexity. So let's understand the space complexity first. So we are using n cross n board size, so it will be big of n square, and recursion depth would be just n because we will just go for the rows, right? So it will not take much time. sorry, not take more space here, right? Space will be just n square, a big O of n square plus n, but it would be n square because because it's a big O, we will take n square. And time complexity of this solution will be, so initially I have n placements, right? I can place in 0, 1, 2, 3. Later, once I place a queen in a particular cell, then I'll have only 3 options. I cannot place in one particular cell, right? Then again I'll have only 2 remaining spots, and then 1, right? So it will be n into n minus 1 into n minus 2 into so on 1, which is nothing but n factorial. So the time complexity of this solution is n factorial and the space is big O of n square. I hope the solution and time and space complexities are clear. Thank you.